In this question, we have a buffer that is made up of 0.3 moles of our conjugate acid, which is acetic acid, and 0.2 moles of our conjugate base, our acetate. The question asks what the pH would be if we added 0.1 moles of strong acid, HCl, to this buffer. So for adding a strong acid, it's going to react with our weak base. So let's write out the reaction. So we have our formate anion, CH3COO-. It will react with our HCl to give us our conjugate acid, CH3COOH, and we're going to have a chloride anion. So if I write out our Rice table, so reaction, initial, change, equilibrium, our initial moles of our base is 0.2, so 0.20 mole. Our initial moles of HCl is 0.1, so 0.10 mole, and our initial amount of weak acid is 0.3. I'm going to ignore the chloride since it's a spectator ion and doesn't affect the reaction. So strong acid like HCl will react as much as it can. The weak base is in excess, so all of the HCl will react. So we're going to have minus 0.10 moles here and also minus 0.10 moles for the weak base. Anything that reacts on the left is going to produce the products on the right. They're in a one-to-one stoichiometry, so we have plus 0.10 moles of our weak acid. Thus, at equilibrium, we have 0.10 moles. We have no strong acid left. It is reacted completely, and we have 0.40 moles of our weak acid. So at equilibrium, we have a weak base and its weak conjugate acid, and they're within this 10-to-1 ratio, so this is still a buffer, and we can still use the Henderson-Hasselbalch equation to figure out the pH. So we have our pH is equal to pKa plus the log of the amount of conjugate base we have over the amount of conjugate acid. So in the question, we're given that the pKa of the conjugate acid is 4.75, so we have equal to 4.75 plus the log of the conjugate base, which we have in 0.10 moles from here, and our conjugate acid we have as 0.40 moles. If we plug that into our calculator, we find that our resulting pH is 4.15.